Thermodynamics. Thermodynamics is the study of the changes in energy that occur in reactions. System. A system is a set of substances and energy that is being studied. Example. Reactions are occurring in a jar. Everything inside that jar is the system. The surroundings are everything not in the system. We have several different types of systems. First one we're going to look at is open system. Open system is a system that may exchange matter and heat with the surroundings. An example, boiling liquid loses matter and it loses heat with the vapor. Closed system. If there is just heat exchange occurring between the system and its surroundings, there will be no loss of matter. Isolated system. If there is no exchange of heat and no exchange of matter with the surroundings. Temperature versus heat, heat transfer and specific heat. Temperature is the measure of the kinetic energy of the particles. Particles are always moving, so the hotter the temperature, the faster the particles are moving. The slower the particles are moving, the colder the temperature. Heat is energy measured in joules. Heat transfer, the amount of heat moved from one object to another. Specific heat is the amount of energy required to increase the temperature of 1 gram of a substance by 1 degree Celsius, or Kelvin. The symbol for specific heat is Cp, and the unit for specific heat is joules per gram times Celsius. Specific heat and why it's important. Several substances and their specific heats. Start out with water in the liquid form, has a specific heat of 4.184. Concrete 0.880. Glass 0.840. Iron 0.444. And copper 0.385. And specific heat capacity at 25 degrees, and the units would be joules per gram per degree Celsius. Why is specific heat important? Specific heat capacity is important because it determines how quickly a substance will heat up or cool down. The smaller the specific heat capacity of a substance, the quicker the substance heats up or cools down. takes a lot of energy to heat up water. Doesn't take a lot of energy to heat up copper. Heat transfer mechanisms. There are three modes of heat transfer: conduction, convection, and radiation. Conduction is concerned with the transfer of thermal energy through material without bulk motion of the material. In other words, through direct contact. As you can see in the picture over here, we have a couple hugging. They are exchanging heat through direct contact. Convection is concerned with the transfer of thermal energy in a moving fluid, such as a liquid or a gas. Hot air balloons will move around through the air using convection currents from the sun. The sun heats up the air and moves the air through the environment. Radiation is the transfer of thermal energy through electromagnetic waves or photons. The energy moves out in all directions, such as a radiator for heat. The heat radiates out in all directions. The first law of thermodynamics. Energy is neither created nor destroyed. It can only change form. The change in the system's thermal energy is equal to the heat added to the system minus the work done by the system. Example: a propane grill does not create energy when it cooks food. Energy stored within the propane molecules and oxygen atoms is released in the form of heat and light when the propane molecules reassemble themselves into carbon dioxide and water. Energy has not been created or destroyed. It has simply changed from chemical potential energy into light and thermal energy.